Good morning, good afternoon, and good evening to all of you all over the world. My name is Marija Krstic, and I am a postdoctoral researcher at the City University of New York. This study was a collaboration between City College of New York and TU Delft in the Netherlands. Today, I will be presenting on behalf of the group the topic assessment of freeze-thaw resistance of cement-based concrete with ground glass pozzolan through X-ray microtomography. I will be talking about research significance and physical and chemical characterization of raw materials used in this study and development of mixture designs. I will be also discussing macro and microstructure evaluations specifically related to freeze-thaw resistance and air void analysis. A main drive for this study was a few years ago when we experienced for the first time inconsistent fly ash and slag supply in US, specifically northeast area of the US. There was a need for a new supplementary cementitious material that is economic, sustainable, and that gives a good performance. Ground glass pozzolan, or today known as GGP, is one of the alternatives because it has many advantages. These materials is environmentally friendly, diverts glass from landfills, supports local economy, and contributes to LEED and green initiatives. This material contains no harmful heavy metals, and it is energy efficient. GGP can be used in cold weather and in precast and pre-stressed concrete. And it is important because in New York, we experience between 75 and 100 freeze-thaw cycles during the year. Some of the challenges that we have faced along the way were consistency in a cleaning process of a feedstock, which is very important. We did not have clearly established standards when we started this study. However, we managed to approve an ASTM standard for ground glass pozzolan in concrete C1866, and this standard was approved in December 2019 and published in April 2020. We also didn't have enough supply comparing to demand in order to be able to use in field applications. However, in December 2020, there was a first large-scale plant opened that produces this material. We have performed some of characterizations of this material because physical and chemical properties of raw materials directly affect properties of cement paste and concrete. By using laser particle size analyzer, we obtain a particle size distribution of cement, fly ash, slag, and GGP that is used in this study, and we obtained that median particle size of GGP was only 10 microns, which was the smallest among all of them. By using XRF analysis, we obtain that GGP contains more than 17% of silica dioxide, which is significantly higher than other raw materials used in this study. LOI was determined from TGA analysis, and it was only 0.4 way lower than for other materials. Ternary plot just shows where GGP stands in terms of silica dioxide, calcium oxide, and alumina content. And in this study, we used GS, ground glass pozzolan, which is soda lime glass. Mixed designs were developed according to ASTM standards and also according to Department of Design and Construction of New York City for sidewalk construction. So some requirements had to be followed. For instance, this concrete had to have air content of 6 ± 1% of air content. Water to cement ratio was 0.4. And there were 3 references: cement, fly ash 30% replacement, slag 40% replacement. So these 3 were references, and 3 mixes with ground glass pozzolan were 20, 30, and 40% of cement replacement per weight. Some of macrostructure evaluations that were performed were static and dynamic modulus of elasticity, and they were compared at 28 days. It is obvious that dynamic modulus is higher than static modulus for various reasons. Some of those reasons are that the geometry of samples was different and the type of load was different. We tested those beams that were 16-inch long and 3 by 4 inches in cross section for dynamic modulus. After curing for 14 days, we tested for initial dynamic modulus, and then we were checking up to 1,000 freeze-thaw cycles. One freeze-thaw cycle as per ASTM C666 was for 4 hours, where temperature goes from +4 to -18 Celsius degrees and goes back to +4. So all this happens in 4 hours, and per standard, the maximum number of cycles allowed at once was 36 cycles. So after every 36 cycles, we would check samples visually for deterioration, and we would also weigh them to check the mass loss and check dynamic modulus of elasticity. All these samples, as you can see on this image here, showed a very small deterioration. Specifically, S40 and G40 showed almost no any deterioration. And also that can be seen here in this graph for relative dynamic modulus versus number of cycles. Mass loss was very insignificant. Slag 40% and glass 40% had only about 0.5% of mass loss, while cement was the only one that had more than 1%. In terms of durability factor, all 6 mixtures showed that they are resistant to freeze-thaw because initially it was air and train concrete. However, we wanted also to see what would be the air void analysis of hardened concrete after some time. So in order to do that, we used microcomputed tomography or micro CT scan, and beams that were exposed to freeze-thaw cycles were used for determining microcracks in the samples, and beams that were not exposed to freeze-thaw cycles were used for taking cores for determining the air void parameters such as air void content, spacing factor, and specific surface of air voids. We use 2 different approaches for determining air void content. So one of the approaches was basically a downscaled linear traverse method from ASTM C457. So we took the cores from the beams and scanned through micro CT scan, and then we coupled with image J and did the image processing. So this method had images taken every 1 millimeter under the assumption that air voids are not larger than 1 millimeter. And then we just applied a regular linear traverse method, just downscaled. So that was one of the approaches, and then we call it 2D approach. A second approach was that we took the entire image stock of a core sample, and we basically applied image analysis for entire stock. So these micrographs were from the beams that were exposed to freeze-thaw cycles, and we tried to see if there are any micro cracks. However, we were not really able to spot any, maybe just because they self-healed after some time, or maybe simply there were not any cracks. All we were able to see were some microporosity, where you see those arrows, and this microporosity just was around the aggregates. These are the micrographs from the beam samples that were not exposed to freeze-thaw, and they were used for air void analysis. Here is the summary of showing air content of fresh concrete when we were making concrete, and it was about 6% or so. And then here highlighted its air void content by traverse method or 2D approach, and by thresholding. And we can see that results are very comparable. So traverse method might be a little overestimated because some of the voids could be a little larger than 1 millimeter, but I would say threshold might be more appropriate. And these two graphs show as well spacing factor, and for S40 and G40, this spacing factor was smaller than 0.2 millimeters, what is desirable for freeze-thaw resistant concrete. And specific surface of air voids was for G40 about 24, 1 per millimeter, and 26.2 for S40. And from the literature, so this is something that is desirable to be larger than 24 millimeter to the -1. And some conclusions made from this study. So the mass loss was close to 1%, and durability factor was above 90% for all concretes except for cement, and that indicates better freeze-thaw resistance. Another conclusion that could be drawn is that using GGP as an alternative supplementary cementitious material serves as nucleation for air bubbles due to its angular particle shape and finer particle size than cement, and subsequently its larger specific surface area. So with the higher cement replacement with GGP, spacing factor decreases and specific surface increases, which is favorable for freeze-thaw resistance. The air void analysis by micro CT scan coupled with image J can be successfully used because it's a non-destructive method, and preparation of samples takes less time, and it shows that results are very comparable. And I would just like to thank everybody who contributed in some way to this research. And thank you for your attention. If you have any questions, I guess that will be after the end of this recording. Thank you very much.